Here's another example dealing with point masses. 3 beads, each of mass m, are arranged along a rod of negligible mass and length L. Figure out the rotational inertia of the assembly when the axis of rotation is first through the center bead, and also when the axis of rotation is through one of the beads on the end. So let's look at part A when the axis of rotation is through the center bead. Well, we know to calculate that rotational inertia, it's the sum of mr squared. And I think let's label these 1, 2, 3. Our first point mass is value m, and it is a distance half L, or L over 2, away from the axis of rotation. So we have L over 2 squared. Then looking at bead 2, it has mass m, and it is a distance of 0. It is on the axis of rotation. So I'm going to go ahead and write out that term here. But as you see, that's going to zero out, and it's not going to affect the moment of inertia in this case. And then looking at our third point mass m again, and this one's also a distance L over 2. So m L over 2 squared. All right, so then just summing together what we have, I'm going to do a little simplifying first. 1/4 ml squared plus 1/4 ml squared means that the rotational inertia for case A is 1/2 ml squared. All right, we're going to see if anything changes when the axis of rotation is now moved to one end of this rod. I'm going to label the same 3 point masses 1, 2, 3, and let's take a look at that calculation. So I is the sum of mr squared, and first of all, the one on the far left, m, but it's a distance of 0 squared from the axis of rotation. So that one's not going to contribute to the rotational inertia. The middle point mass here is a distance L over 2 from the axis of rotation. So we have m times L over 2 squared. And then the third point mass plus m, it is that full distance L from the end. So ml squared. Here for the third mass, a little bit of simplifying, 1/4 ml squared plus ml squared means that our rotational inertia for this case is different. It's 5/4 ml squared. And so now we can see, even if we have the same distribution of point masses, where they're rotating about, where that axis of rotation is, does affect the rotational inertia.